Good day, everyone. This is Glenn Tan speaking. I'm from Grid Training Department. It is an honor to have such a great chance to be with you. And during the presentation, if you had any question, just mark it down. And at last, we will have a Q&A time. Then you can ask your question. Thank you for your cooperation. Today, we're going to talk about the photovoltaic direct-driven GMV. It is short for PV GMV. This presentation divided into these 5 parts. First is the product introduction. And this is the product lineup of all our grid PV products, including the air conditioner for household use, split tie, and this is our famous PV GMV for VRF. And also we have the rooftop. It is very popular in Middle East and Africa area. And also we have our centrifugal chiller. It is PV. And also currently we are developing this cold storage. Also we use the PV energy. Today we just focus on this PV VRF. Maybe other manufacturers also claim that they also have the PV VRF, but actually it is not that same. And here I will explain how they work. So you can find it on this graph. This is for example the regular VRF, and this is the converter. It's handling the power, either it's from AC, which is from the grid power supply, or from the DC, is from the PV panels. So for this case, this converter need to, for example, if get the power from this DC, and you need to convert this DC to AC, then power to the regular VRF. And for the compressors and fans inside, if they are DC, which is very popular, they need to convert this AC to DC again, then to drive the inside compressor and fans. So the total convert loss there are 6%. It is for 2 times. But for our PV GMV, which is this one, so you can find it. We also have a converter, but it is built in, which means this is actually the regular VRF, and we buy them together. So on the side, you just need to connect the power from the grid power supply, which is AC, and then here is the power from the PV panels is DC. We can use the DC to drive the inside compressor and fans, so we can eliminate this 6%. And on the other hand, this can also improve the construction speed, as you don't need to set up the converter, so it's easier for you to install it. And this slide explains how this PV GMV works. So for the mode 1 is not uploading to the grid, which means you get the power from the PV panels only for the power consumption of this PV GMV. So for this system, first is it can consume 100% the power from the grid power supply, and this of course just acting as a regular VRF. And also it can consume the power 100% from the PV panels. And also it can mix them together, which means if here the power is not enough, we can also get the insufficient part from this grid power supply. And all these 3, they are all automatically, no need to set anything. So for the mode 2 is uploading to the grid, and this require the local policy, which means the local policy, if it allow, you can upload to the grid power supply to earn some money. And for this one, first is pure PV power generation. That means if this PV GMV, which this one, is not working, so at that time, here the PV panels still generate the power, and then you can upload to the grid power supply to earn the money. And the next is the balance, which means here generate much, then we can also power the PV GMV and also uploading. This is the perfect, right? And also for this two and also once setting, there's no need to change. And for the third is PV storage integration. That means if not allowed or you don't like to upload to the grid power supply, you have a third option, which is to stop the abandoned power to this what we call energy storage unit. So at this you can find it that is actually a transformer, which is we will lower the voltage of this DC and then stop the power to this battery. Actually for this one you can buy it from grid, or you can just prepare yourself and just follow our requirements. It's okay. And for example, in daytime you can stop the abandoned power to here, and after sunset, or if the power from the PV is not enough, you can also get the power from this. And for the fourth mode is we can also offer the power to other home appliances. And from here it is DC, but actually you can just add another DC to AC converter, so you can also power the AC home appliance. And for the last one is the off-grid PV system. For this one, for example, you just would like to use the VRF on an island, but it is there's no grid power supply. But so for that one, you can also use this PV powers, but we require to install this power generator. The purpose of this one is just to stabilize the power voltage. And the next is I will introduce the core technology. For our PV GMV, there are these 5 technologies. Actually, it is a little bit complicated, and also from the name you can also find it. And actually, for this one, the power generation and consumption management, and this is just we're making the power consumption and power generation to be visualized, and also this is convenient for you to analyze and management. And this PVG1 direct G1 technology, that means we can drive the inside complexer and the fan motors directly from the PV panels, which is also DC, and so we can higher the efficiency by 6 to 8%. As for this 3, the PAWN interleaving technology, multi-converting technology, and dynamic load checking and PPT technology. The 3 of is aim to lower the PV power fluctuation, as you know that especially when it switch from the PV panels power to the AC power, which is from the grid power supply. If the tie loss is too much, it will make the compressor to stop. And for this 3 technology, we can avoid this. And next part is PV equipment selection. And this is for the side discharge. For this series, we have 38 to 60 kBTU, and although it cannot modularize, but it's very good for the household use. And actually this one is, you can find it is very similar to the GMV Mini, and the answer is yes. And actually it is the GMV Mini but plus the PV function. So on the service menu you can also find this parameter. It is the PV parameter which is very important for you to do the selection. And as for the torque discharge, and it is similar to the GMV5, which means for the single unit we have 62, 96, 120 kBTU, and for modularized, which means we can put different outdoor units together to enlarge the capacity. So we can make this to be 360 kBTU. And for this one, it's actually the regular GMV5 plus this converter. It is built in, but actually for the North American market, we make this separated for the delivery. And also for the PV selection, this is the important parameter. You can also find it on the service menu. And later I will show you how to do the selection. As for the indoor units, for this part is completely the same as the regular VRF. And this is the centralized controller special for the PV-GMV. And here is the model. And as for the connection quantity, it is the same as the regular VRF system. What's different is, and you can find it from here. Actually, this is very similar to the CE53, and the difference is just here. From here, it will show you the detail of the PV system. So you can find it. We already display the how much power this VRF comes out, and how much power from the PV panels, and how much we get from the grid power supply. And also this 3 icon here, you can click on it, and then it will show you the detail. The first one, we will put it all in the parameter, and the next is press here. And also we can see this one. This is the, we make the data to be curved, which is much more convenient for you to do the analyze and also the management. And this one is the another curve. And this is the centralized controller and how to do the wiring. And also similar to the CE52, and here is the terminals of the CE55. Here is for the power supply, and in the system for this part, it is the same as the regular VRF, and this is connected with the slave indoor unit and outdoor units. So this is the master outdoor unit. From the master outdoor unit, if there are only one system, you can connect from the D1, D2, which is from here, then connect to here, which is here, the G1, G2. And also don't forget the matching resistor to ensure the communication. This is for single system. If it is a multi-system, only from the master G1, G2, just like this, and they can combine together from here and then connect to this G1, G2. As for this F1, F2 is for the fire alarm, and once we see the fire signal, this centralized controller will stop all the online operation. And this is the energy storage unit, which it is the battery. And also you can connect with the G-IEMS system, which later I will introduce. And the purpose of it is just to stop the power. What you can do is we can adjust the electricity for the price at peak hours. That means, for example, if in your local, if the electricity fee during the daytime and nighttime is different, so we can adjust this part, which means we can stop the energy during the daytime and use it in the night. And the next is the G-IEMS system. And first is this is the topological. And for this one, and this is the PV system, which is the outdoor unit and the indoor units, and also including the PV panels. And for this one, also from the master outdoor unit from G1, G2, you need to connect to this gateway. And here is the model. And also for this system, you still need to install the power meter. One is for DC. This is to calculate or to measure how much power you get from the PV panels. And also another is from the AC. This is to measure how much power you get from the grid power supply, and if it is available, which means you can upload the power, we can also measure this part. So for this one, it is a binary, which is from and to the grid. And after that, from here, you need to connect to the server on the Ethernet cable. Then from here to a PC. So from the PC, actually it's on the west side. You can also control and check the system information. And this is the homepage of the G-IEMS system. Its function is all engineering customized, which means you can change the detail. Just contact with our salesman. And also you can check and do the management from your smartphones. And here I will just show you a project which is in Dubai. So from here you can find it when you go into this website. Here you can make a selfie to introduce what's the project, and also this is DIY. And for this data, we make the power consumption for every day, for every month, so make it to be curved. It's better for you to do the analyze. And also you can find from here, this is the PV panels, this is the storage, the battery, and here is the how much power you consume, and here is how much power you get from the grid power supply. And also on this one is the CO2. We make it to be a CO2 animation, which is more popular. And on the other hand, you can also check and control the indoor units from this software. And from this one, from this example, you can find it. This is display how the indoor unit works. And just click one, and here is the control page. You can control the indoor unit to operate. Next part is how to do the design of the PV system. As for the cooling and heating load, it is completely the same as the regular VRF. You can just follow that to select the capacity. And here is the PV system. First, you need to check how much the solar power for your local. And here is two methods. First is you can check from the NASA website, and the other is from this software. From here, you can get the average solar power for LV squared. So after that, you can select the PV panels, and our grid can also offer the PV panels. And currently, there are 3 models of it, and you can find it the size. They're the same. The difference is the max efficiency and also the power output. And when you select this one, and you need to ask the manufacturer what is the efficiency and also the power. And this is the detail of these PV panels. And for your selection, this parameter is important, which is the maximum output of this of each panel, and also this 4, the max voltage and the open circuit voltage, and also this 2, and this 5 parameter is very important for you to do the selection. After selected the PV panels, and then you need to combine them together as a string and connect this string to the PV outdoor unit. And the first step is to calculate how many panels for one string. And the formula is this one. And then the next is to calculate how many strings for one outdoor unit. And the formula is this one. And for this also you can find it. This is the P is for the max DC power of this solar outdoor unit, which we listed on the service menu. And here the PS, that means the N, this is the quantity of one string, which is this one. At the step 1, you calculated value. And this WP, that means the maximum output of this panel. And of course, for this one, finally you can get this string quantity. The higher of this value, that means you can connect more strings. Also means you can save more power. So I will show a detailed example to do the calculation. And also you can find it, there is we also make Excel files. This is for quick calculation only. So this is the Excel file. When you open it, it will just display this table. For example, this time we already selected the outdoor unit to be this one. And on the service menu, we can get the PV parameter of this. So from this selection table, this part, you need to input the parameter of these PV panels, including this Pmax and the other 4. And also this one, you can get from here. And input from to here, and then this one is your local temperature. You need to input it, and the last, it will automatically coming out how many panels for one string. From this calculation, it is 10. And then the next step is how many strings for this outdoor unit, right? So also from this formula, this P is this one, the max PV input power. From this one is 6. So you put into this formula, you can get this result to be this is only one string. And one string is for 10 pieces of the PV panels. And for the other case is, for example, this time we just select the top discharge. It is this model. And also this parameter, you can get it from the service menu. So from the calculation table, for this part is completely the same. Just input the parameter of these PV panels, and for this part you can get it from here, and here is your local temperature, and here it will get the results automatically. So if this is correct, and you can get for one string there is 21 pieces of the PV panels. And how many strings? You can get the P from here is 14 kilowatt. So finally we can get max 2 strings. And as for this one, it is the max 14 ampere for each string. This for you to do a double check. As for the A series, it is a little bit different, but generally it is the same. And for this parameter, you can get it from the nameplate, and also input to here. You can get that for one string there are 20 pieces of the PV panels, and also from the formula you can get for this outdoor unit, for this A series, there are maximum 2 strings. And here is a summary for your reference. And for the top discharge and side discharge, you need to prepare for top discharge 42 pieces of the PV panels, and for side discharge only 10 pieces. And as for the PV panels, the lifespan it is about 30 years, and with the decay factor less than 20%. And for the next part is how to do the wirings. And first you need to decide where to install the PV panels, and which from these three, which is the best angle lying and the flag install. And this is the also flag install, and according to different cases in the cement flag, steel roof is best for the factories, and this is the galvanized tile roof for the household use. So for this one, this is the before and after. And also for LV square meter, how many or how much power of this one can generate, we can also write here for your reference. And then the next is just to combine the PV panels together, which is just to connect the minus and the plus together, just like this one, make them series connected. And we use this MC4 fast connection. It's much easier to do the connection, just like this. And after the connected, you need to check the open circuit with the multimeter. It should be within this range. If there are multi-strings, and the voltage difference between these strings should be less than 10 volts. And if this cable, the length is more than 200 meters, you need to consider about the cable resistance. And last but not least is as you need to periodically clean the PV panels. As you can find it, there are lots of the dust and will accumulate it on the surface of the PV panel, and this will lower the PV efficiency. So we strongly recommend to do the cleaning about this one. And next is how to do the wiring from the PV panels or from the grid power supply to the PV GMV, which is this one. And from here you can find that we separate the power from the PV panels, and this is only for the A series as we don't have the converter, so we need to set up another converter. The purpose of this one is just to avoid the lining damage. And also the same for the AC distribution cabinet. This is also to avoid, the purpose is just to avoid the lining damage. If you have already fixed this lining damage, you can also combine them. You can also eliminate these two parts and do the wiring directly into the converter. Next is the detail of how to do the wirings, and this example is for this model. And after you do the wirings of the PV panels, and just pay attention, don't mix the positive and negative. This one. And also check the insulation resistance with the mega meter before laying the cable down. And also this cable will require to do the protection. And on the outdoor unit, you just open the panels, and here is what you can see. And this is connected to the DC power, which is from the PV panels. So you can just plug in this MC4 into here. It's okay. And this is for the power supply from the AC power. And this is for the communication wire to the indoor unit and for the centralized control. And as for the C series, for the torque discharge, and for the requirement is the same, which is for this part is the same, and inside is just a little bit different. And here is the converter, and this is the PCB of the control. So, and also as you know that for the North American market, the converter and the outdoor unit, they are separated for delivery. So on site you also need to combine them together. And here is this is the at the bottom side of from this one. So you need to connect the AC power to here, which is through this hole. And from the PV panels, you can connect directly to here, which is here. And also as they are separated, this is converter separated from the outdoor unit. Also you need to do the wiring, which is the VDC to here, and also the RS485 to here. And the other end is already connected on the outdoor unit. Which is here. This is RS485. As for the A series, and it is more easier, so you can find it. Here is for the communication wire to indoor unit or outdoor unit, and here is for the DC power supply. It is from the PV panels. And also here is for the AC power from the grid. And after that, you need to do the commissioning. This is especially for the torque discharge and especially for the C series. So for that, just follow these steps. This is additional step just compare with the regular VRF, which including the QP, which is for the grid connection certification, and then QU is the power supply setting, and the QN is whether you need to upload or not upload to the grid power supply, which standard is this one. So for this one, QP, according to different area, this is standard, and also the certificate is different. And also the QU is to set the three-phase power supply, the parameter, including the voltage and the frequency. And the QN is to select whether you need to upload or not upload to the grid power supply. And after that, it's just the regular commissioning stage as the regular GMV. As for the commissioning methods, it's the same. You have this, you can do on these three, which is from the outdoor unit PCB, from the debugging software, which is from your PC, and this is the portable debugger. But the setting of these three parameters is only can be done on the outdoor unit PCB. And as for the site discharge, it can be done just after the commissioning and before the commissioning, especially for C series. You need to do this one. And for the last part is the investment analyzed. And first, I will just make a comparison between the A series for torque discharge and the C series for also torque discharge. And here is the difference. The important part, I already make it to be different color. So the first one is for the C series, it is available to connect to the power module, which is the battery, to stop the abandoned power if you don't would like to upload to the grid power supply. And for the C series is available to upload, and also inside this combined box. And next is the max PV input. For the C series, we increase to 14 kilowatt. And last is the economy comparison. I just compare two plans. So for the plan A, it is a regular VRF plus the PV panels. So as it is a regular one, which means we need the converter. But for the plan B, it is the PV GMV, just plus the PV panels. And also from the outdoor unit, you can find it. This is the regular model. This is the PV GMV model. So next is the PV panels. As the power, as the capacity of the outdoor unit is the same, so the quantity and also the price for this part is the same. And for the converter, we need to set up for this one, and also additional installation cost, which means we need to connect the PV panels to the converter, and from the converter to the outdoor unit. Also, we need to cost the installation fee. So for general, the initial investment for the plan B, we can save about 3%. And then the next, I will analyze from the operation, and this is the total power generation from the PV panels for the whole year. And you can find it, the total amount is the same, but just due to the efficiency, as you can find, just like what I introduced introduction. And for the PV GMV, there we can higher the efficiency, as we don't need to convert the DC to AC and AC to DC again, so we can save up to 6%. Is this 6? We can get 6% higher. So from the PV panels, we can also get 6% higher, right? So for this one, we can get higher PV efficiency. And so from this, we can convert into the power generation. And here is the totally for the 30 years, and just consider about the decay factor of the PV panels. You can find it drops every year, the decay factor. And finally, we can get the total power generation and divide it into 30 years. So we can get for every year, here is the power we can get from the PV panels. So from the plan A to plan B, here is the difference, which means for the plan B, we can get every year for this value, the power we can get from the PV power. And here is the total comparison. So for the PV panels, it is the same, and also the average annual power generation here is different. And according to your local electricity fee, which means this part, if it is higher, which means you can get a higher profit. So this is different, and so we can get the payback time. Just use this one initial investment divided this 3. So here is the result. It is about 4 months earlier you can get the payback. And that's all for this presentation. If you still have some problems or any questions, please feel free to contact me with this email address. So thank you again, and bye bye.